So EV vehicles, okay, actually it is the platform structure. It is based on which kind of EV the structure will be defined. Okay, we have a two kind of EV platform structures. One is a native EV and non-native EV. The native EV means, okay, there is a purely designed, the complete EV structure has been defined for the electrical vehicle. And non-native EV means, okay, earlier some vehicle which have IC engines that directly convert into the EV. Okay, I will give some example. Tata Nexon. Okay, the Tata Nexon vehicle. Okay, we have a IC engines. Okay, the same platform slightly has been modified in order to accommodate the EV structure. Has been designed in order to accommodate the area which already has been designed for the IC engine. So the battery has been not designed a flatter battery. Okay, wherever the lower area, okay, which already designed for the IC engines. So the battery has been designed without modifying the previous platform structure. Like that, they have been made the battery. The major disadvantages of this kind of changes is we can't have a bigger battery. Okay, we have some limitation. Okay, so without modifying the IC engine parts, okay, we have to accommodate the battery. Okay, whereas the native EV means it's a pure EV, like a Tesla models. Okay, the Tesla doesn't have a IC engines, so this kind of a flatter, bigger battery that can be used. Okay, for the new Mahindra, okay, they have been used the battery, bigger battery like this, like a XE6E vehicle or XE9E. These vehicles, they have been used completely new platform for especially for the EV. Okay, whereas they have been created the XV 300, they convert into the EV. For that, they are using the previous generation IC engines platform, and the battery has been fitted according to the previous platform structure. So this kind of battery pack, it will be on the non-native EV. Okay, whereas the native EV, that is the pure EV, which contains the bigger battery. Okay, here this is the battery which is modified in order to adopting their ICE typical body structure. Whereas this Tesla model, which we have a bigger battery, there is a no IC engines. Directly, it's a pure EV vehicle. Okay, so now I will let me explain. The upper body, okay, it will be a variety of structures will be there, like a sedan type or SUV hatchback models. Okay, and this area, the platform structure almost the structural wise it looks same. The upper body, okay, this area, each area, this is the front hood area, fender area, and these structures, okay, the pillars we used to name it as A, B, and C pillars. Okay, so these are the major BIW assemblies. Okay, the BIW structure, okay, it is assembled in the manufacturing plant in a sequential manner. Okay, based on the part where it is located. Okay, we used to keep a number of assemblies. Those assemblies are come from suppliers. This assembly we will collect it and we will assemble in our manufacturing plant. Okay, so most of these assemblies are sub-level assembly or supplier level assembly. These assemblies are integrated together in order to make the complete BAW structure. All these assemblies that I will explain you where it is located, under each assembly what all the parts will come, that I will explain to you. Okay. So before that I want to give some concepts. Okay, if you understand the concept, then when I explain this outer assembly and inner assembly, what does it means? Okay, you can understand better. Okay, so the concept, let me explain. Okay, for the BAW structure, I mentioned that the panel must have enough strength and stiffness. Okay, in order to have a better strength and the stiffness, okay, the structure, whatever the things we have to define, it must have the closed structure. Okay. This kind of closed structures. If you maintain this kind of closed structure, then when we apply the load on this closed structure, it withstand the load. Whereas if we have keep on the open structure, okay, like this, okay, these are the closed structure and these two are open structure. Okay, when we apply the load, the same load on this structure, okay, several kg of load if you apply, then the same several kg of the load if you apply here. Okay, it withstand the load because all the area completely it is covered. Okay, it will withstand several load, but this is open end structure. It is not located anywhere, not mounted anywhere. Okay, if we apply load, okay, it easily get deformed. This two structure compared to this two structure, right? So for the better strength and stiffness, we have to keep our structure. Okay, it has to be completely closed structure. But in the BAW structure, okay, it is made up of styled data and multiple parts are getting mounted on the BAW structure. Okay, so we can't make the stamped parts by using a single structure like this. Okay, we can able to make only the open-ended structure through the stamped parts. Okay, the closed structures can be achieved through the extrusion process only. Okay, the stamped parts we can't able to get through this. The closed structure we can't able to achieve. So In the industry, what they used to do, okay, they will take two open-ended structures, two open-ended structure parts they used to take, okay, then the two open-ended structures they make together, and these two open-ended structures they will weld together. So the two open-ended structure parts forms the complete closed structure. Okay, this is one open-ended structure parts that can be achieved through the stamping process. This is another open-ended structure parts, okay, which can be achieved through the stamping process. These two parts, they will get it together and they form the complete closed structure. Okay, that is why. So each area we have a outer panel as well as the inner panel. All the area like A pillar have a A pillar outer panel, inner panel. B pillar have a B pillar outer panel and inner panel. C pillar have a C pillar outer panel, inner panel. The hood, we have hood outer panel, hood inner panel. The side door, we have a side door outer panel, inner panel. The tailgate area, tailgate outer panel and inner panel. All the area we have outer panels as well as the inner panels. Is this concept is clear?
Yes,
Yes,
sir.
sir.
Okay, thank you. In the next session, let me explain about the nomenclatures, like what is each assembly, where it is located, and what all the small parts that will be integrated. That I will explain to you in the next session.